Okay, let's talk about weightlessness. Okay, so we're going to use an elevator as our weightless object. Um, so our first case, here we have elevator, our spring scale, our mass on it, and the elevator has zero acceleration. So basically it's at rest. So the forces on our mass here are mg pulling it down, the force of tension pulling it up. Okay? So if we sum the forces in the y direction, we have the force of tension minus mg. And since there's zero acceleration, the sum of the forces have to be equal to 0. So the force of tension is just equal to mg. Okay? So now let's take our second case. Our second case, we have our elevator, our spring scale, our mass, and this time we're accelerating up at 1/2 the acceleration of gravity. Okay. Now, if we were accelerating up, then you would think that the force of tension here would actually be greater than mg, right? So if you're in an elevator, it accelerates up, you would feel a little bit heavier, right? Okay, so let's take a look at how that works. We have the sum of the forces in the y direction, the force of tension minus mg, and our acceleration is up, so we have a positive ma, right? The sum of the forces equals mass times the acceleration. Okay. Now we solve for the force of tension here. Force of tension equals mg plus ma. Now we know that our acceleration is 1/2 g, so I just plug that in for our acceleration here. And we get mg plus 1/2 mg. And 1/2 plus 1 gives us 3/2, so the force of tension is 3/2 mg. So a little bit more than mg. So you would indeed feel heavier. The force of tension is heavier. Now, if this acceleration was down instead of up at 1/2 g, then you would think that you would feel lighter, right? And in that case, that makes this term here negative, this term here negative, this term here negative. So you have 1 minus 1/2 g. So you would end up with a force of tension being 1/2 mg instead of 3/2 mg. Okay, so you would indeed feel lighter when the acceleration was down. Now our third case. Now in our third case, we're accelerating down at negative g. Okay, so the negative sign is telling us that we're heading in the down direction. So again, we sum the forces. We have the force of tension minus mg equals negative mg. Okay, or the mass times the acceleration being negative g. Now, when you solve this for the force of tension, we get mg minus mg. mg minus mg is equal to 0. Okay, so the weight that we feel would be equal to 0, and this is what we call the apparent weight. And when the apparent weight equals 0, that's when we get weightlessness. So this weightlessness is the same thing that the astronauts feel once they get up into orbit. So when the space shuttle takes off, they feel a great force on their backs because you have mg plus the acceleration to get you there. But once they cut off the engines and they're in orbit, they feel weightless. Okay? Now, when they feel weightless, it's not because they're not feeling the force of gravity, right? Gravity doesn't turn off. What's happening is, as you're going around the Earth, right, you're actually falling towards the Earth, but you're going fast enough that you're falling around the Earth. Okay, so you're actually always falling at the same rate. Okay, and that's what makes it feel like it's weightless. Okay, and this is also the same thing when I was drawing here was what do they call it? The vomit rocket, where they take an airplane, they take it up, and then they make a big dive, and they come back up, and they make another big dive. And when it goes into this diving spot, you actually feel weightless because the airplane is falling as fast as you are falling towards the earth. Okay? So if you were taking off something like this, your trajectory in projectile motion would make a parabola like this, and if the plane follows that same parabola as it goes down, you will get the feeling that it's weightless because the plane and you are both falling at the same rate, okay? The rate of acceleration of gravity, okay? Then when you get to the bottom, you have to curve back up, and then you can do it again and again. But you can't do it for very long because this fall is actually going at very high rate of speed, okay? So that is weightlessness.